Every story has a beginning. For our universe, that was the Big Bang, a moment 13.8 billion years ago when everything erupted from an unimaginably hot, dense point. We can trace the expansion of space back to this primordial fireball, but what lit the fuse? What happened before the beginning? This isn't just a deep question, it's a forbidden one. As we approach that initial moment, our most powerful theories, Einstein's general relativity and quantum mechanics, simply break down. The equations that describe the very large and the very small become screaming paradoxes. At this wall, at the edge of time, our understanding ends, but our most daring ideas begin. Perhaps there was no before at all, only the potential of nothingness. This isn't an empty void, but a seething cauldron of potential governed by quantum physics. In this realm, the laws of reality allow for energy to be borrowed from nothing for fleeting moments, creating a chaotic foam of virtual particles. From this foam, a tiny bubble of spacetime could have randomly fluctuated into existence. This microscopic seed, smaller than an atom, then underwent a period of hyperexpansion called inflation, stretching faster than the speed of light to become the vast cosmos we see today. Our existence, a grand cosmic accident, born from a statistical burp in the void. But what if there was no true beginning, just an endless cycle? Imagine a prior cosmos that lived its entire life, stars burning out, galaxies drifting apart into a cold, empty twilight. Then gravity, the patient architect of the cosmos, began to pull it all back together in a colossal, big crunch. As it crushed down, the rules of quantum gravity took over, preventing a final, infinite collapse. Instead of an end, there was a rebound, a great bounce that released all that compressed energy into a new Big Bang, ours. In this view, our universe is but one chapter in an epic, timeless story of cosmic rebirth. A third, and perhaps the grandest theory, suggests our Big Bang wasn't the beginning, but just a beginning. Imagine that quantum foam not as a one-time event, but as an eternal, bubbling ocean. This is the multiverse. In this cosmic ocean, new universes are constantly branching off, each bubble with its own unique roll of the dice for the laws of physics. A universe with stronger gravity, another with different fundamental particles, an infinite tapestry of possibilities. Or perhaps, our universe is the child of a black hole from a parent reality, a new space-time blossoming from the singularity of another, creating an endless cosmic family tree. These are not answers carved in stone, but tantalizing glimpses from beyond the wall of our understanding. They remind us that the ultimate mystery isn't just what we know about our beginning, but that we have the courage to ask what came before. Imagine the universe as a grand cosmic recipe. To create it, you need ingredients like matter and energy, but you also need a set of precise instructions, a series of unseen numbers that dictate how those ingredients interact. These are the fundamental constants of nature. They are the source code of our reality, woven into the fabric of space-time itself. They don't change, they don't have an explanation, they simply are. And the most remarkable thing about them is the knife-edge balance they hold. If any of these numbers were just a tiny fraction different, the universe as we know it would be impossible. The most famous constant is c, the speed of light. It's more than just a velocity, it's the universe's ultimate speed limit, the fastest that any information or causal link can travel. It's the c in Einstein's legendary equation, E equals mc squared, which tells us that energy and matter are two sides of the same coin. This one number governs everything, from the flow of time to the immense energy locked inside the heart of a star. If c were different, the very relationship between matter and energy would be rewritten. Then there's the gravitational constant, g. This number dictates the strength of gravity, the cosmic glue that pulls matter together. It's why planets form from dust, why stars ignite, and why galaxies dance in colossal spirals. G is remarkably weak compared to other forces, which is crucial. If it were slightly stronger, stars would burn out in an instant and collapse into black holes. If it were weaker, galaxies and planets would never have formed at all. The entire large-scale structure of the cosmos is held in a delicate truce by the precise value of this one number. Perhaps the most exquisitely tuned constant is the fine structure constant, alpha. This number governs the strength of electromagnetism, the force that binds electrons to atoms and allows for all of chemistry. If alpha were just a few percent different, the stable atoms that make up our world, like carbon, couldn't exist. Stars would be unable to fuse the heavier elements necessary for life. This single, dimensionless number is the master architect of all structure, from a single molecule of water to the building blocks of you and me. The speed of light, the strength of gravity, the rules of chemistry. Why do these constants have the specific values they do? We honestly don't know. Perhaps it's the only way a universe can be, governed by a deeper, undiscovered law. Or perhaps we are just the winners of a cosmic lottery, living in one of the few universes among an infinite multiverse where the numbers happen to be just right for life to emerge. These constants aren't just numbers in a textbook. They are the silent, unwavering rules that make our existence possible.